Welcome back to ARC 12 Builds. This is part 2 of the tailstock project. So over here, I'm cutting the internal left-hand acme threads. It's a 10 TPI thread. And I have my micrometer depth set to the left of the saddle, so I know how far I have to go in to begin my threads. And I have the dial indicator there so I can go back to 0 every time I'm finished threading. Overall, the setup was nice and smooth, and I feel a lot safer cutting left-hand threads since I am feeding away from the work and you can't really crash it. So over here, I'm test fitting the tailstock handle, and the threads are going in fine. No, they're not binding up. There's a little bit of play in it, but the original tailstock quill has about the same amount of play in it. I just wanted to replicate the fit so the handle can move smoothly in there, and it has enough space to be oiled up. So I had to bore out the material on the quill end of this part, so the threads and the tailstock handle will be able to make it through the part without binding up. So this is a 45 64th inch drill bit. It was the longest drill bit that I had. I would have liked to have gone smaller, but for what it's worth, it ended up working out just fine. So here the drilling is all done. And I thought that I could just simply grab the part, but not putting two and two together, the part was super hot. And I'm just gonna clean out the insides before, and clean out the threads before I test fit the threads for the tailstock handle. So this is the part with the threads finished. Let's see if the tailstock threads go in. There's a little bit of movement, but I'm not too worried about that, since it will be in the lock position. That locks pretty well right there. Let's see it compared to the actual quill. Actually, the movement is actually pretty similar. It's not so bad. And then it'll be the same exact motion all the way to the end, locks up. So overall, I am happy with how the internal left-hand threads came out. The action is smooth, like the original tailstock quill. See, the threads came out pretty nice. I'm always happy when that happens. Lets me know that the geometry of the cutting edge for the high-speed steel is on point. It's always good if something does break on the lathe, potentially I can fix it. That's also another plus. That's also just good for practice. Okay. I'm going to be using this milling attachment for the southbend lathe. I'm going to be using it to cut the keyway. And I have to cut the keyway the full length of the quill end of this part so that it can fit the key inside the tailstock end. And this milling attachment gives you full adjustability, allows you to swivel it and angle it depending on the job that you're doing. And you have Z-axis up and down by moving that handle. And obviously you have the X and the Y on the cross slide and on the saddle. So I'm going to be using a 3/16 end mill in this Bison 5C collet chuck to cut the keyway. I believe it's a high-speed steel end mill. Over here, trying to find center of the part by using the ruler method. So you take the ruler and you pinch it between the end mill or the tooling and the part until your ruler is vertically plumb. There is a level of inaccuracy with this, obviously, since I am doing it by eye, but this is all I really had at my disposal. And you see me right there, I'm trying to see if I can squint my eyes enough to be able to find exact center. So I'm just going back and forth, just trying to see if the tooling is lined up. So for the first pass, I took a light pass. I got about a 5 thou pass, and I only have the RPM set to around 600. I just wanted to make sure the rigidity of the setup wasn't going to be compromised in any way. I didn't want the part falling out, damaging the ways, since I do only have one block clamping down on the part. I couldn't get the second one in there. But overall, it seems to be working. So I did feed everything by hand for a couple passes until I felt comfortable enough to turn on the auto feed on the cross slide. And I started taking about 15 thou passes. Overall, I feel like it was probably like around maybe 7, 8 at most passes to get the correct depth for the keyway. I did end up switching the end mill to a different one. I believe it was a Niagara end mill. Still 3/16. But I was able to crank the machine up to, I believe the max speed is 1200 RPMs on these lathes. So I just cranked it all the way up and I just let loose with it. Here's a view of the lathe in action with the crossfeed, auto crossfeed activated. And I gotta tell you, this lathe, when I got it, it was in great condition, and it's been really good to me. When I first got it, I took it all apart, completely cleaned it, and I've gone through this whole machine. It's still original paint. I didn't paint anything. I just cleaned it all up and oiled everything and degreased and all that stuff. And I gotta tell you, it's been a beast so far. The only thing that it makes me want now is a bigger lathe and a milling machine. So maybe those two will come in the future. So moment of truth, I finally got to test out the part in the tailstock, and it was wonderful. The keyway was cut correctly, and the threads are great. Everything's moving nice and smooth, just like the stock quill that comes with these lathes. It's perfect. So all I have to do now would be to drill the 2 set screws that are going to go to the front end of this part to be able to hold the adjustable die heads in place. So over here, I'm center punching 2 marks I made to drill out the holes for the set screws. I decided to go with 2 Allen head socket cap screws, and they are M8 by 1.25 pitch threads. This is a Walker Turner drill press that I'm using. It's a 900 series from, I believe it's the 1930s, 1933, 34. And I have a 2 horsepower treadmill motor hooked up to it with variable speed control. So maybe I'll make another video on how I set that up. I also have, I believe it's a 3 horsepower motor on a belt grinder that I have. Same thing, treadmill motor with the same motor controller, speed controller hooked up to it. So over here, I started with a 3/16 drill bit that ended up dying on me. Totally crapped out. So I swapped it out for a 7/32 drill bit, and then I finished it off with a letter G drill bit, since I did not have a 6.7 millimeter drill bit. This is the letter G was the closest I can get to the 6.7 millimeter, so that I can tap these for M8 by 1.25. So this is the part fully assembled with the adjustable die head. And I gotta say, this thing looks completely overkill on this 9-inch lathe, but it's awesome. I'm happy I was able to make it without any issues. And I'm just happy that I was able to do it at all. So here's the adjustable die head in action. This is a 1-inch rubometric die head. And I was just making sure that the plunger worked to release the threads, to open up the threads. And I just had to adjust the tension on the pulleys, make them a little tighter. And this thing grabbed instantly. It was a little hard pulling the plunger out. It did not want to release at first, but I gave it a nice little tug and it pulled out. It should be a lot easier to pull out the plunger to release the threads, but I'll just have to learn how to use the adjustable die heads a little better. So over here, I reset it just to see a smoother action. Catches the threads every time. Pull the plunger, and that's generally how adjustable die heads work. And then you pull the plunger in the back, and it releases it without having the need to turn the lathe in reverse to exit the tool. So it was a neat little project. It was fun seeing how far I've come with machining over the past year, and just coming up with new things off the top of my head. You know, I didn't really have plans for this. I didn't have any real sketches other than the chicken scratch drawings that I made when I was first coming up with the idea. But everything came out great. I'm really happy with how everything came out. And the threads you can see right there, threads are pretty nice. This project was a lot of fun. It definitely tested my patience and why I really love machining and fabrication. So hopefully you guys join me next time as I continue to learn more machining practices. If you guys enjoyed the content, please comment, like, and subscribe, and I'll see you guys next time.